Hi, welcome to Mr. Ferris Science Classroom. Today is March 31st. This is NTI Day 11, and we're going to go over eclipses and tides today. Let's go. NTI 11 assignment, tides and eclipses. You're to watch this video, complete the notes section of your packet using the PowerPoint slides in the video. We will not be using the article or the questions because of the limited time before spring break. You must take a picture of your completed notes and submit it as a grade to Google Classroom, or you have to turn it in at school and let me know that you've done that. I have a lot of students, 5th period, 6th period, and 7th period, that have not turned in anything to me over the first 10 days. We need to get to work. All right, today we're going to talk about eclipses and tides. We're going to be using the following vocabulary words: umbra, penumbra, solar eclipse, lunar eclipse, and a tide. I'm going to try to make this brief because I want to go over some of the notes section and highlight a few things as we go. You will also have this PowerPoint on the Google Classroom along with my partially completed notes to guide you and the original notes and PowerPoint that you had from the handout that I gave you week 1. There are two kinds of shadows on an eclipse. The first is the umbra, which is in the center of the page where the darker spot is, where the light source is putting a shadow from the ball. The lighter outside ring is called the penumbra. These are two distinct lines, and if you were at the eclipse back 3 years ago, you would have seen the penumbra from here in Kentucky. You would have had to travel further south to see the umbra around the Tennessee border. The umbra is the central darker part of the shadow where the light is totally blocked. That is called a total eclipse. The penumbra is the lighter part around the outside, which is partially blocked, which we call a partial eclipse. A solar eclipse is during the new moon phase, when Earth, Moon, and the Sun are lined up and the Moon casts a shadow on the Earth's surface. When the Moon's shadow appears on the Earth's surface, a solar eclipse is occurring, and there is a very good picture at the bottom of that slide that you can look at where it shows the cone shape of the umbra and then the wider of the penumbra. During a solar eclipse, the moon appears to cover the sun completely. You can see the total eclipse within the moon's umbra. So if you're in that small band, as you're looking here, you can see where it says path of the total eclipse. That is the only spot, if you're standing in that particular path, that you would be able to see the complete blocking of the sun by the moon. When you see a partial solar eclipse within the moon's much larger penumbra, so it's a partial eclipse. The sun appears to change during the eclipse and moves in the sky. So you can kind of see a time lapse there, but the main thing you know is that a partial eclipse is not completely blocking out the sun's light. The moon's orbit is slightly tilted compared to the Earth's orbit, 5 degrees above, 5 degrees below, which means that we don't always have a solar eclipse every new moon. That means we'd have one every month. But the way the Earth is rotating around the sun, and the way the Earth and the moon together are revolving around the sun, that's why they happen very infrequently. Now, a lunar eclipse is just the opposite. The lunar eclipse is when the Earth casts a shadow on the moon. These happen much more frequently because of the fact that the Earth is much larger than the moon, so therefore it can pass through the shadow more frequently. But a lunar eclipse is when the Earth is in direct line between the sun and the moon. When the entire moon moves through the umbra, the total lunar eclipse occurs. That's where you get that kind of reddish moon. It kind of has a kind of a funky blood color on it. That's not the same as a blood-colored full moon, so don't get confused about that. Now, when only the moon passes through the umbra is a partial lunar eclipse. The lunar eclipse can only occur on a full moon phase. So full moon, lunar eclipse, new moon, solar eclipse. That's because the moon has to either be between the sun and the earth for a solar eclipse, or it has to be on the outside of the line where the earth is in between, in a straight line, between the sun and the moon. Now that we've talked about eclipses, now we're going to briefly talk about tides. If any of you have ever been to the ocean and you've been to say Florida, or if you've been even to California or places along the Atlantic coast, you notice that wherever you put your beach chair in the morning, the tide is either getting closer to your chair as you start the day, or it starts getting further away depending on what time of the day that you do this. That is called the tide. A tide is a daily rise and fall of the sea level. It is primarily about the moon's gravity causing the Earth's ocean to rise and fall twice each day. The moon's gravity is slightly stronger on the side of the Earth closer to the moon and weaker on the side opposite the moon. That's kind of funny, but it's going to make more sense here in a minute. The gravitational difference causes a bulge. So when the moon is in direct line over the ocean surface, that is when you're at high tide. If you go 90 degrees, where the moon is not over that, you get low tide. The opposite side of the earth is also experiencing high tide. So, half the ocean is high tide, half the oceans are at low tide simultaneously, which means at the same time. As the moon rotates, the high tide shifts around the oceans of the world. High tide occurs at the tidal bulge, which is where gravity kind of pulls the water slightly away from the Earth's surface. And low tide occurs between them. That's when the water is being pulled inward or lower. Because the sun is so far away from the Earth, its effect on the tides is about half of the moon. So it's much bigger, but yet the moon is much closer, so it has a little bit more effect. It's kind of like a magnet. If you have a big magnet far away, it's going to have less effect if you have a smaller magnet that's closer to whatever you're trying to move with the magnet. The spring tide is when a full moon or new moon phase is occurring. The spring tide means that the combination of the sun and the moon create higher high tides and lower lower tides. So that makes a lot more sense when you start looking at the way they line up. So spring tide is at new moon and at full moon. They're in a straight line. The sun, the moon, and the earth are kind of in a straight line. Not in an eclipse line, but in a straight line. Then the opposite is the neap tides. Those are at the third quarter. So the moon's going around the earth. So it happens at the first quarter and the third quarter when we are at a right angle. The sun, the moon, and the earth are at a right angle. A neap tide occurs a week after the spring tide, when the sun, earth, and moon form a right angle, and the sun's effect on the tide reduces the moon's effect. So that means it's split. So it's being like pulled in two different directions. So it's instead of being pulled in the same direction, it's being pulled in two directions at a 90-degree angle. So high tide happens twice a day. Spring tide is when you have really high tides. Like if you're at the beach and you're almost all the way up as far as you can when you're barely on the beach and the tide is coming in, it's almost reaching your chair. That's a spring tide. When you go to the beach and there's all the sand and it seems like the tide's barely coming in, that's a neap tide. That means it's really, really low. So you'll have kind of low high tides and higher low tides. So it's kind of all stays in the middle. Now I'm going to switch over to my camera and I'm going to look at the notes section just for a moment briefly. we have the notes section marked NTI 10. It says complete lesson 3 handout. So your assignment for today is very clear. You have to complete this notes section, take a picture of it, and or turn it in to me, but send me a note. So as we're doing this, you can use the notes, your PowerPoint notes that you have from your packet. So I've given you PowerPoint notes. You should have those in your notes section. And the first thing it says, define umbra and penumbra. So we said that the umbra is the central darker part of the shadow where the light is totally blocked. This is a total eclipse. The penumbra is a partial eclipse. So those are the two major differences. Now if we look, here's the picture we had on the PowerPoint. The darker spot the arrow is pointing to, this is the umbra. The lighter one is the penumbra. So as we go through and we fill out this notes section, I want you to just simply look back at your notes, look at what the video says, and be able to complete each section. Now if you notice, at the bottom of the page, this first page, it talks about solar eclipses. And there's 4 bubbles to fill in. So you have to put the definition of a solar eclipse. What phase does it happen for the solar eclipse? The solar eclipse has to happen on the new moon phase. And the difference between a total eclipse and a partial eclipse is when the umbra passes over Earth. The partial is when the penumbra passes over the Earth's surface. So as you can see, this is very simple to be able to do. You look at your notes, you go back to the PowerPoint, and you should be able to complete these. Now, there are 3 pages to this, so this is page 1. You have the back of page 1 that talks about where you have to identify the different parts up here at the top. Okay? So obviously this is the sun, this is the moon, this is Earth, this is the penumbra, because it's pointing to the lighter part, this is the umbra, and you're finished with that part. So as you're doing this, just make sure that you take and look at what's going on there. If you have any questions, please send it to me through Google Classroom. This concludes the video for today. I hope that you'll be able to complete this notes section. And remember, today is just a math and science day. Thank you very much.